Welcome to All Things Policy, a daily podcast by the Takshashila Institution. We are a bunch of policy nerds based in Bengaluru, and we like bringing fresh perspectives to Indian affairs and Indian perspectives to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello, welcome to today's podcast of All Things Policy. I'm Sridhar Krishna, your host from Takshashila Institution. We're going to discuss how robots can give India a fresh chance to increase labor productivity, increase its share of manufacturing, and make India more prosperous. For having this discussion today, I have with me Arvind Vasu, an old friend and a Chennai-based entrepreneur, investor, and expert in the field of robotics and industrial automation. He leads the Indian operations for Robot Systems Products, a Swedish company specializing in peripheral equipment for industrial robots. He established Avatar Business consulting practice to help European companies, especially those in automation and IoT, enter the Indian market. In the early 2000s, he led the establishment of ABB's Robotics division in India and was responsible for its expansion in India until his departure in 2010. Arvind is frequently cited as a thought leader in the Industry 4.0 space, often advocating for the potential of robotics to create higher quality jobs in India rather than simply replacing human labor. And I think this is very critical for India, Arvind. Thanks for joining us today.
Thank you, Sridhar, for having me. It's my pleasure.
So I think it's an important issue that for India has been very proud of the fact that we are now number 5 in GDP globally. We're just closely behind Japan and then whom we may overtake very soon. And then there's Germany, which also shortly we will become bigger than Germany in terms of GDP. But India is quite far behind when it comes to per capita GDP, which is really important from a perspective of it tells you how rich or poor our country is and our people are. India's been plagued with low labor productivity. I mean, when you compare it with China, India's hourly output is only around $10 per hour, while China is almost $20 an hour, right? And India has a potentially larger workforce. I mean, we have a young workforce, we have a potentially larger workforce, but our workforce participation rate is significantly lower than China's. And China has been clearly the undisputed leader in manufacturing in terms of its efficiency, automation, the infrastructure, and they've all had historically much higher output per worker and so on. They are about 10 times India's size when it comes to manufacturing. We have a large number of our population in agriculture, which is not very productive. We have a reported low unemployment rate. But then with a low labor force participation rate, it means that there are not enough great jobs for people to believe that they can get a job, so they don't even apply for one. Women's labor force participation rate in India is particularly low. And so also plagued by the fact that most of our manufacturing jobs are in companies that employ less than 20 people, and women don't feel very safe working in very small organizations. Women feel safer historically working in organizations which have large number of people working. So they feel there's safety in numbers. And manufacturing share of employment in India has not increased despite India's efforts over the last few decades trying to increase it. It's always been between 15 to 17% of our GDP of our employment has been in manufacturing. And our stated goal is 25%. I mean, China is at about 25% or 25 to 28% of their employment is in manufacturing. So now coming down to it, and we've now got there may be many reasons for it. I think we're not going to go into those details. There have been some new labor law reforms which have taken place, which could change the face of manufacturing in India. But the reason we're having this conversation today is because of this renewed interest in robotics, especially with the advent of AI. So, Arvind, I know that you've been involved in robotics for quite some time. I mean, at least formally for the last 25 years, but I know you and I know that you've been involved in it even longer. So do you want to first tell the audience how you got interested in robotics and what's been your early forays into this topic?
Yeah, sure. Thank you, Sridhar, for that good summary introduction of the background to this, which led to this talk. I was born in Sweden and grew up here in India, in Chennai, but moved to Sweden to for higher studies to do my master's program in engineering. And during that time, I developed an interest for robotics, having done a robotics course at the university. And then I knew that I was not going to end up being a programmer, even though my degree was in computer science.
Mm-hmm.
So I opted for a lot of other electives apart from robotics, like industrial economics and marketing and so on. And I always had an early interest in the robotic space. And when I did my master's thesis, so happened that I had done a few summer jobs at ABB, and they sponsored my travel in India. And my thesis was to look at how new technologies were being adopted in emerging economies. And of course, I used India as a test case for this,
Mm-hmm.
and I ended up doing a market survey for at that time ABB, but for the university, of course, it was more on adoption rates and how technology spreads and gets adopted in new parts of the globe. So that's how it started, and later on, I ended up joining ABB as a management trainee, and first worked in the information technology company of the firm, and later moved to the automation space, more in process automation, where it was about selling control system products to the industries like chemical, oil and gas, cement, and steel, pulp and paper, etc. And I was moved around. So I one day when I was working in China, one of the management called me into a conference room, and someone had remembered this market study I had done and said, "Young
This
man,
way
would you
back
like?"
in 1990 was the market study.
Yeah, it was back in 1991, and then about 10 years later, 2014, I got the question, "Would you like to go to India and start up our robotics business?" So that's
Ah,
how I came back to India in late 2004 and started the business at ABB. And it certainly was one of the more exciting periods in my career.
I think we reconnected around that time. I think when you moved to Bangalore, right?
Yeah, that's right.
Right. So tell me this. So robotics is not new. Robots have been around for a long time.
Yeah.
I know that the automobile industry has used robots for quite some time. So do you want to give us a brief history of robotics? I mean, not so that people who think that it's the AI and humanoid robots, etc., which is the future, and they think that's what robotics is all
Mhm.
about. I mean, but robots have been around for a while. You want to give us some
Yeah, I
history
think
of that?
the robots have been around since the 60s. The first robot to be deployed was the Unimate in the US, a collaboration with Kawasaki in Japan.
Okay.
And they were basically built to resemble a human arm, and so that they could grip objects, move them, manipulate them, etc. But the first significant modern robot came out in 1974. It was ABB's division, robotics division in Sweden, which at that time was still called ASEA, came out with a robot called the IRB6, which had an Intel chip.
Mm-hmm.
It was microprocessor controlled, it was electrically driven, and it could be programmed with a computer language, similar
Mm-hmm.
to Pascal, you could say.
Yeah, I remember learning Pascal when I was.
Yeah. So you could probably then program the robot, but the robotics has evolved because the robots at that time, when you programmed, you had to be rather good at imagining Cartesian coordinates and x, y, and z in space, and moving the robot's arm from point A to point B when you made the program. Eventually we got also these joysticks, which were part of the robot controller. There used to be a little device on a cable where you could move the robot arm to a certain point in space, memorize that position, and then move it to the next position where you wanted the robot to go and do a certain operation. And in the 80s, we started getting offline programming, and later on in the 90s, you could simulate with 3D CAD models, the environment around the robot, the actual robot model itself, and save a lot of time in programming on the site. Today, it has shifted after 2000, 2010, it has shifted to being able to disengage the gearboxes in the robot, and so that a human can actually pull the robot's end of arm to wherever they want to position it. So there are so many ways of programming a robot, and by doing simulations, you could plan your processes better. You could plan the position of the robot, where they would be, what kind of peripheral equipment was required, did you require safety fences around it, etc., etc. Today, with the advent of AI, we are getting a whole new set of methods to program robots. You can even talk to the robot and say, hey, move your arm from this position to this position, and it can do that.
You don't have to physically move it. You can just tell
You
it to
don't
move.
have to. We have collaborative robots which you can physically move and adjust positions, just the program for different variants, etc. AI is also, now we have generative AI. So we are getting a lot more inputs. Earlier we've had vision for a long time connected to robots, but it used to be 2D vision. Now it's 3D, and 3D with depth. So robots can learn. If you program them to manipulate a part, say an automotive part, they can then also quickly adapt to different sizes of that part. Or we're also seeing people doing kind of learning for this AI models that allows the robot to visually inspect the object that needs to be grasped or picked up and manipulated by studying it. And then the learning model gives it a perception of whether that is a soft object, a hard object, whether it is best to grip that object at a certain position, to balance it right, to find its center of gravity, and a number of other things.
Yeah.
So it's getting more complicated, and being able to, for a worker in a factory floor, to program the robot is getting easier. Reprogramming is
So
being
basically, its
simplified.
abilities to do more. Its robots have increased in their ability to do more things.
Yes.
They've become more dexterous. Become more capable of sensing things, not just vision, but also by touch, and figure out what they need to do to manipulate the object better.
That's true.
And one of the big reasons for using robots in the past has been because they can do things with speed. You can run a factory 24/7. Robots don't get tired. They can, unlike human beings,
Correct.
You can continuously run the plant. You can do things with greater speed. I mean, therefore, they do it. They do it with greater precision. It can be. Those were the advantages. So, what do you think has changed? I mean, are those still the reasons why people deploy robots? I mean, are there other reasons why people may deploy robots?
Well, the traditional reason to deploy robots was, to get rid of jobs which were dull, dangerous, and dirty. So
Dangerous, dirty.
dull would be like repetitive tasks,
Yeah.
very boring for an assembly worker, not challenging enough, and easy to fall asleep on the job, perhaps. But
Right.
I'm just joking.
Yeah.
Dangerous could be, heavy lifting of very heavy objects, things that can fall and cause injury to factory workers.
Or even for diffusing a bomb, for instance, right?
Yes, there are military applications as well, as we know. And dirty would be the environment, could be hot, a lot of smoke in a weld shop. There could be sparks flying. There could be furnaces close by where robots would have to pick hot billets out of coming out of a oven and then being pressed or formed into blocks or rods. Those are the jobs we did. So we did it to protect human beings, and we also had to protect the human beings from the robots themselves, which could be massive, as in lifting up to couple of tons of not only a workpiece that the robot was working on, but also the gripping mechanism could be so large that it
Mm-hmm.
and it moves at 6 meters per second, and then obviously somebody coming in the way could suffer a
Yeah.
serious injury or death. So today it's more about something else. We are automating to win on quality rather than anything else.
Mm-hmm.
I think when I first started working with robotics in India in 2005, there was many customers. Automotive were the early adopters of industrial robots, and many customers were automating partially. So they
Mm-hmm.
would say 40% automation or 50% automation because they were leaving the dangerous, dull, and dirty jobs to the robots. But then they had stations where they had a workforce doing the assembly, etc. It wasn't as productive as the industry demands it to be today.
Huh.
So that was how it was in the late 90s, early 2000s, at least in India.
Okay. So how is robotics changing the face of manufacturing globally? So what kind of, I mean, we read about factories where there's no light on, they're
Yeah.
dark, like robots just work, they produce, and out comes a car or something, right? So I think we hear of things like that. So, but is that the future? Is that what you see? I mean, are you just going to see factories which are just run completely by robots, or is that way out into the future? What's happening
We're
today?
already seeing factories run completely by robots. These kind of lights out factories do exist.
Yeah.
But to be able to do that, you have to ensure, very high precision or consistency in the child parts that you're using to manufacture. For example, if you are in the business of welding, say, sheet metal, which a lot of automotive tier one suppliers are doing, then they usually farm out the manufacturing of child parts to two or more sub suppliers, but not all suppliers are making the part exactly the same.
Uh,
And if you do an arc weld on a seam or a joint, the robot is not going to be able to adjust for deviations.
uh,
That has been the challenge so far. Of course, you can use software which has a camera and can do seam tracking, etc. But it just leads to more occasions where quality suffers.
So, in order that, robots can be successfully deployed today,
Mhm.
I mean, at the current level of technology, I think having some things, this child parts being consistent is a key criteria. But
Yeah,
when that's not the case, then you still are going to use humans to do that job.
that's true. And I've done a number of consulting assignments for industries in India, and especially if the customer has a brownfield installation where they have existing machinery which is really old,
Hmm.
then they need to secure the process by making sure that they sometimes have to adapt their own product to suit the robots.
That's very interesting, Arvind.
Yeah.
I think the way you mention it, I mean, typically we imagine that you have an existing process, much of it is manual,
Hmm.
and you want to automate, you want to use robots to do it. You just take you break down your workflow into maybe 10 different steps and say, here are 3 steps that robots can do easily. There are some steps that,
Yeah.
like you were mentioning the other day, that there are some steps that robots can't do very well,
Yeah.
needs human beings also to be around, and some which you would probably not use robots for.
Mm.
That's something which is easy for us to understand, right? You say take 10 steps and say deploy it here.
Right.
But what you're saying now is that sometimes the product itself needs to change. Because
Yes.
what do you mean by that? Is it because when you design a product, its shape and form and size or whatever is also based on the manufacturing process itself?
Yeah, because if you go from a process which is not automated to something that is highly automated, you need not only the robot, but you need a lot of peripheral equipment around the robot, fixtures to hold the parts together before you glue or weld or etc. And if it was done by a human being, of course, a human being can adjust for errors. Let's say this screw hole for the nut wasn't exactly the way it was in the position it was supposed to be in.
Mm-hmm.
You can adjust and fit a part on top of that, and it could still pass through quality control at the end. However, for a robot, you need repeatability. You need to be exactly in that coordinate to perform that operation. So if it's slightly off, it's not going to work. Then the line's going to stop and you got to reject that part.
Yeah, that's very interesting. I think like that's something for people to think about a little bit when you're deploying robots in your factory. But how's China so successful in manufacturing? Has robotics played a part in its success?
Oh, China has certainly had a lot of help from robotics, but they started as a manufacturer where cheap labor and the large labor force that they could deploy, not only when it comes to a number of people, but they were able to cluster all their supply chains in small radius. So if you go to Shenzhen and Suzhou and these kind of manufacturing hubs, you will see the cluster power is the supply chains are within a 10-kilometer radius.
So all the suppliers just sort of hovering around, clustered around that little big mother factory.
Right. So and then their infrastructure, logistics costs are just about 7 or 8% of GDP, whereas in India our logistics gap is like we are like 14% of GDP is logistics. Of course, the government now is trying to improve on that with better infrastructure, good quality highways and roads, but within the cities, it is still very congested.
Right.
So that's one reason. They have in China stock of 2 million robots. The government has actually gone and in the last 10-15 years this has happened, that they have encouraged indigenous robot manufacturing and supply. So it is today the largest market for industrial robots, and that's because Chinese labor costs have gone up. They need to stay competitive, so they need that. So every year 50% of the robot installations around the world happen in China. In fact, more than 50.
And like China, like we mentioned earlier, has like a very significant share of manufacturing around the world. They are about 10 times the size of India in terms of overall manufacturing output. And I read that they have like you said, I mean, they have about 470 robots or something per 10,000 population, while India has only like, some 7 robots per
in
10,000.
reality, probably slightly less than 7 per 10,000 workers.
Yeah, per 10,000 workers. So I think it's
on the other hand, you could say that India has this enormous potential.
Right. That's a good way of looking at it. Like our school teachers used to tell us, right?
Yeah.
I mean, your marks may be low, but yes, you have enormous potential. There's a big gap to fill.
That's right.
So I think robotics has played a role and their infrastructure and the fact that all these, their supply chain is clustered around a small region. And I think
we have a very fragmented, infrastructure. And like you mentioned earlier, many manufacturing units have only about 20 employees on average.
Yeah, which means that you don't have that scale. You don't have that scale to be able to deploy. So how does that change for India? Let's say that our labor law reforms take off and companies are now more willing put in more effort to not just remain small, but now they start having global aspirations of scale and size and so on.
Yeah.
Then, so that's one thing which needs to change in our country for us to be able to. We need to start thinking big. We need to be thinking about like building something not just for import substitution kind of thing, but really producing to become like globally competitive enterprises of scale. And what else do we need from an ecosystem perspective for robots to be deployed more widely?
There's already a lot of activity in projects from, for example, job creation. Because the problem with our, first of all, the labor force is that we have a lot of labor, but not enough of them have the right skills,
Correct.
or they're 80% basically totally unskilled. Some industrial belts that I've seen are they company owners don't know whether the same person in the in the labor pool is going to show up the next day or not.
Right.
Especially in these sweatshops where you're welding or hammering out all these dull jobs which don't need much skill, but
Yeah.
still welding requires. I mean, when you teach a robot to weld, you're usually imitating what the human being is doing. So there are policies. For example, Niti Aayog projects that they will generate 100 million jobs. Or there are also studies that say the fuel for the policy has to be these production linked incentives, which will attract a lot of investments. So, if you could have production linked incentives and still at the same time our the cost of industrial robots, particularly the cobots, which are cheaper, they don't have the capacity to lift such heavy loads, but up to 20-25 kilos payload is something they can take.
Mhm.
So it is still affordable to a smaller company. So if we could get these, I don't know how many thousands of companies with 20 employees each to afford the robots, we could boost our productivity, and that would be really the second chance for India to catch up.
Yeah, I mean, the way I think about it is not if you just look at India's manufacturing GDP at about $500 billion or so and say that instead of having people do this work, let's have robots do some of it. You'll end up with maybe a situation where you need fewer people. But if you think of robots as a way for India to move from 500 billion to $2 trillion of manufacturing output, or even $1 trillion of manufacturing output, then you're talking about actually increasing the labor productivity by like using things like cobots, which will enhance the labor productivity, rise it up, and actually help. And as labor productivity goes up, I mean, wages will also hopefully increase, and that increase in wages will lead to greater prosperity all around. So I think in a country of unskilled or low skilled people, I liked your sort of analogy of using cobots to help increase labor productivity.
Yeah, they're really becoming more affordable. So, each robot costs, the cost is down to between 10 lakhs and 20-25 lakhs. So, there should be an incentive to invest in them because you're going to need it to attain productivity and more important, quality. Because otherwise, all those orders are going to go to Vietnam and countries in Malaysia and other countries like that, which are in our neighborhood.
Yeah, I know. I think we have this thing in India where we've been not very good at mass producing any goods, right? I mean, we're good at some custom manufacturing, etc., but we haven't been able to manufacture anything at great scale and that can change if you have higher quality and like precision and consistent outputs, all those things, and robotics can help in sort of India getting into that segment. I think our electronics manufacturing is a case study, a recent success story.
Yes.
And I think that's something that's happened.
We have, three different sectors. Automotive has always been an early adopter of robot technology, and we see good examples of that in Maharashtra, Karnataka, Tamil Nadu, even NCR. And there, if you look at the positive side, India is now ranked the sixth largest consumer of industrial robots in the world. And this has jumped since the pandemic. In 2023-24, it jumped 56% or something like that. And 2024, our number of robots deployed was over 9,000. which is a record for India. Of course, China is at 320,000 or something, so 30 times.
Right.
But yeah, everyone is looking at India in terms of overseas multinationals wanting to set up
Yeah.
production here, and even smaller companies, medium-sized companies from Europe and
Yeah.
the West and other places.
Absolutely.
So,
India's manufacturing growth has to come from that, right? I mean, it
yeah.
has to come from not just the larger companies, but also the medium sized companies. Sorry, I think you were saying something else.
So in terms of the looking at labor, the skill development will certainly contribute to better jobs. That's I've been saying that for a long time, because there's always been a question of, will robots take jobs away? Of course, some jobs are going to be taken away by the robot, where these dull, dirty, and dangerous jobs, especially. On the other hand, we will create at least per robot, we will create half a dozen different jobs. People who are programming the robots, people who are maintaining the robot, people who are doing other kinds of logistics tasks around the production, those jobs will
Mhm.
be
Will go on.
created, and they will be higher paid.
Awesome. I think that's really what we want, right? So
Yeah.
we are not looking for. I mean, whenever people talk about job creation, and I used to look at. I was running a project at Takshashila for creating jobs in India a while back, and one of the things that come up is, yes, we have a large number of people. We have 18 million people who turn 18 every year. We have about 100 million people surplus in agriculture. We need to create 20 million new jobs each year. But I think it's also important to recognize the changing face of manufacturing, the developments in technology which are there today, which
Mm.
means that it's not enough if we just create more jobs. We need to create jobs which pay well, jobs
Yeah.
which are safe and not dangerous for people to be working in. And robots can come in, and we need to produce goods of world class quality and consistency. And from what I've heard from this discussion, you feel that robotics could help us to go in this
Yeah,
direction.
because we are not automating to save labor. Of course, some
Yeah,
people are labor costs in some areas are going up.
sure.
Labor showing up is unreliable, but we aren't automating to save labor. We are automating to win on quality.
Absolutely.
And another thing that the government could do is encourage that a lot of material for automated lines are still being imported. We need to build actuators, sensors, and a bunch of other things in India,
Mm-hmm.
because it has to be available here.
Mm.
Yeah, I currently run a company making industrial robot peripherals and accessories, and we are seeing that a lot of things that we have to produce here, only about 40% or less are available in the Indian market. Most of it has
Mm-hmm.
to be imported, because the well-known brands are for electrical connectors, and a lot of things are even cables.
Mm-hmm.
Cables are not that simple. They have to work. They're going to work with a robot. They have to work in these environments where there may be sparks flying, there may be heat and dust and etc. So they have to be specialized cables. They're all being imported at the moment.
Yeah. So I think, being able to produce some of those peripherals is going to be critical. And
Yeah.
the trade policy needs to be aligned to allowing us to do these things more effectively. So this is a great conversation, Arvind. Thank you very much. I think, so do you have any sort of final thoughts on, how optimistic are you about all this, and what do you feel?
We are very optimistic about India, particularly since we have such a young labor force that it's not too late to train them with the right skills. So as we are looking forward to 2030, I think, like we've discussed, the lack of scale has been a problem, but there's a fresh chance now for the youngsters who are entering the labor market, not only learn to code, but get enough skills to deal with the AI tools and other technologies that are coming, because those will be the ones that ensure that they get the jobs that they need.
Thank you, Arvind. This has been a pleasure and a great conversation. I hope our listeners benefit from this as much as I did. Thank you.
Thank you, Sridhar. It's been a pleasure talking to you.
If you liked our show, dive into Takshashila's research on technology, strategy, and economic affairs. Check us out at our Twitter handle @Takshashila INST or our website takshashila.org.in.